Hey everyone, we are looking at this problem in our projects right now where you're going to be solving this quadratic equation with that leading coefficient of 8 in the method that Tia is describing here. She says, I like to treat it like a quadratic function that I'm trying to put in vertex form by completing the square. I can then use the square root to undo the squared expression. So we're going to be looking at a very similar problem. We're going to look at this one and we're going to solve it in that same method, which is completing the square for vertex form. So first things first, I'm going to rewrite this in standard form. So I'm going to move this 2 to the other side. 2x squared plus 3x minus 2 equaling, and I'm going to write it as a function right now. So I'm leaving that as a function of y. Yep, I want to do that. Okay, so now to complete the square, you always have to have that leading coefficient of 1. So I'm going to divide everything by 2. So if I divide this by 2, what I do to one side, I do to the other side. So 2, yeah, that's not right, because 2 divided by 2 is 1. So they are gone, so I just have an x squared plus 3 halves. It's that 3 being divided by 2x. Negative 2 divided by 2 is a minus 1. And this side is going to look messy, but I don't care. I'm just going to start leaving it as messy. So to complete the square, my job is to figure out on this side, I want to factor it, and I want it to be factored into a perfect square. So right now, this 1 is what's throwing us off. So I'm going to move this 1 to the other side. So x squared is 3x. I'm purposefully leaving a blank space right there. And I'm moving that 1 to the other side. So I would add 1, add 1. Okay, remember I said I'm purposely leaving a blank space because I need to figure out what should be added here so that this is factorable. So I need to figure out a very specific number so that I can factor this left-hand side. So if I figure out what that number is, what I add to the left, I have to add to the right. Okay, there is a formula to figure out that very specific number. That formula is a constant, or I'm sorry, that value is a constant, so I'll call it C. And it is by taking your B value, which in this case is 3 halves. We are going to cut it in half, and then we're going to square it. So lots of fractions here. That's okay. Grab a calculator. Bear with me. We're okay. 3 halves being divided by 2 would get me 3/4. And then if I square that, 3 squared is 9. 4 squared is 16. So this is the number that I'm going to add to both sides. So I would have x squared plus 3 halves x plus 9/16 is equal to y over 2 plus 1 plus 9/16. All good. So the whole point of that, the whole point of coming up with this number, which is kind of a scary looking number with a fraction, is that I can factor this side. In fact, it is so nice to factor that it's going to be factored times itself. And there's a little trick here, that factoring is always going to be an x plus this number here. Remember how we took the b and divided it in half, or cut it in half? It's always going to be that. So it's going to be b divided by 2. So in this case, it's 3/4, which is equal to y over 2 plus 1 plus 9/16. Okay, still hanging with me. We now have an x plus 3/4 squared. That's equal to y over 2. And I'm going to just combine these. 1 plus 9/16. I know that this 1 is really 16 over 16 plus 9/16. So 9 plus 16 will get me 25. And as you remember, we always keep the denominator. So I have 29/16 here. So now I want to start solving. But remember, we weren't solving. We were solving for when the output is equal to y. We moved that 2 to the other side. So what would be the 2 minus 2? It's when the y is equal to 0. So I'm going to replace that y with a 0. Well, 0 divided by 2, well, that's just 0 plus 25 sixteenths. Hey, 25 sixteenths. Okay. Oops, 4. Okay, now I can start to solve. She said that we're going to undo the square. So there's my square, my exponent of 2. What I do to get rid of that is square root. So now I have x plus 3/4 is equal to, please don't forget your plus and minus. Whenever we square root, we have to have a plus and minus. So I have plus and minus. The square root of 25 is 5, and the square root of 16 is 4. So now I'm going to subtract my 3/4. And I would have negative 3/4 plus and minus 5/4. So this is where I need to separate my plus and my minus. So I'm going to have one option that starts with that negative 3/4, and it's going to be adding to 5/4. Second option would be negative 3/4 would be subtracting with 5/4. So here I'm just going to start solving or simplifying. Negative 3 plus 5, positive 2, and then 4. Final answer of 1/2. Here I would have negative 8 over 4. Final answer is 2. So that is how we solved using completing the square.